and welcome to the Chemistry Academy. In this video we're going to go over addition reactions in relation to the National 5 Chemistry course. So you'll learn about addition reactions in Unit 2, Nature's Chemistry, alongside all of the homologous series stuff. And addition reactions are a specific type of reaction in which you get two molecules reacting and joining together to form just one molecule as a product. So that's essentially what you want to look for when you're trying to identify an addition reaction, is you're looking for two molecules that essentially add together to give you one thing. The good thing about the addition reactions, if you think of addition, we usually think of maths and adding, is that for an addition reaction you generally need a molecule that has an equal sign in it. So we don't actually call it an equal sign in chemistry, it is called a carbon-to-carbon double bond. If you have a carbon-to-carbon double bond, then it means the molecule can undergo an addition reaction. So you can add either a diatomic molecule or water onto it to make a new molecule. The double bond has to be between two carbons. Sometimes you will see a double bond between a carbon and an oxygen atom, but that's not the type of double bonds that are allowed for addition reactions. It has to be a double bond between two carbons. Okay, so if you can see an equal sign in the molecule, it can undergo addition reaction. So just think of that, maths, but don't call it an equal sign, call it a carbon-to-carbon double bond. So as far as addition reactions go, addition reactions is like the generic type of reaction in the name of the reaction, but then we also get specific types of addition reactions depending on what you're actually adding to that molecule with the double carbon-to-carbon bond. One other word to remember is that the presence of a double carbon-to-carbon bond in a molecule means the molecule is unsaturated. So again, any molecule that is unsaturated can undergo addition reaction. And this is why the bromine test works for unsaturated molecules, because if you add bromine solution to a solution with an unsaturated molecule in it, then the bromine will react with that molecule, and that's why it loses its brown colour, so it will rapidly decolorize and become colourless. And that's because the bromine can react with your unsaturated molecule. If you were to add the bromine solution to something that was unsaturated, if you were to add the bromine solution to something that was saturated, so it had all single bonds already, then you wouldn't get that colour change because the bromine can't react with it. Okay, so that's how the test for unsaturation actually works. It's just using an addition reaction to tell us if something has a double carbon-to-carbon bond or if it doesn't. So if we go through some of the more specific examples of addition reactions, we've got hydrogenation. So hydrogenation is where you add hydrogen to the molecule. So then we've got bromination, where we're adding bromine to the molecule. And then we've got hydration, which is where we add water. Hydration and hydrogenation are often confused with each other, but just try to remember that if you drink water, you're hydrating yourself. So the hydration is where you add water. Hydrogenation is hydrogenation. It's got hydrogen, full hydrogen name in the word. Okay, so try to not get them confused. What we're going to do now is draw the products of addition reactions, because that's a common thing you need to do in your exam. So what happens is when the addition reaction occurs, essentially this double bond, carbon-to-carbon bond, opens up like a gate. Okay, so when you're drawing the products of an addition reaction, the best thing to do is take your alkene, or the unsaturated molecule, and draw out as you can see it, but with no double bonds. So I'm just going to draw all the atoms that are already there, but I'm not going to put the double bond in. Okay, so see how that's essentially just that without the double bond. Then I'm going to take where the double bond is and open it up like a gate. So that means I get an extra bond here and an extra bond here. The H2, that's a diatomic molecule, that splits up and the two hydrogen atoms add across the double bond. So each hydrogen atom goes to one of the wee open gate places. And then that would be the molecule that we make. So here we've gone from having but-1ene to making butane through hydrogenation. Okay, so that's what happens when you hydrogenate an alkene. You make the alkane with the same number of carbons. So if we were to hydrogenate pent-1ene, then we would make pentane. If you were to hydrogenate ethene, you would make ethane. So that's something that's good to bear in mind as well. Then if we go on to the bromination, so it's just the same thing, same process. We draw the alkene again as if it didn't have any double bonds. So just copy down everything you see, but don't put the double bond in. Okay, so then we can see where our gap is normally. So here was our double bond, so that opens up like a gate. And this time, instead of there being 2 hydrogen atoms to add, the 2 bromine atoms split up, and then 1 bromine goes here and the other bromine will go here. You don't need to name these products, you just need to be able to draw them or identify them in a multiple choice question. And then if we look at hydration, so again, exact same process, draw the alkene as it is but without the double bond in it. Okay, so we've got the 1, 2, 3, 4, 5 carbons. So then we can see that our double bond is going to open up here. Water is, as you know, H2O, but it splits up to give you a hydrogen atom and then an OH. So it splits up into hydrogen and a hydroxide. So that means that one side gets a hydrogen, the other side gets the hydroxide. When you're drawing the hydroxide on, just make sure you clearly show that this carbon is bonded to the oxygen and not the hydrogen. So don't write it like this, where it looks like it's the hydrogen bonded to the carbon. You need to clearly write the oxygen at the end of that bond and then just place the hydrogen next to it, or you can put the hydrogen underneath like that, okay? But it can't be showing to be connected to the carbon. However, for this one in particular, I've missed a hydrogen here. For this molecule, we actually could have done it the other way around, where we could have put the hydrogen on this one and the hydroxyl group on this one. So we'll do that as well. So again, just the same alkene. So 1, 2, 3. Okay, so our double bond opened up. So then we could have put the OH here and the H here. And again, see, I've shown that the carbon bonded to the oxygen. So we can actually get both of these products. They are 2 different things. These you would be expected to name because they are alcohols. They have hydroxyl groups on them. So this one here would be a pent and 3-ol, because the hydroxyl group's on carbon 3. And this one here is pentan 2-ol. Okay, so you will get quite a few questions on this concept, that you can end up forming 2 different things. And remember, these things will then be known as isomers because they are made up of, they've got the same molecular formula but a different structure. So these can be, you can either make the pentan 3-ol or you can make the pentan 2-ol. This happens when the alkene is not symmetrical across the double bond. So it doesn't matter when we're adding diatomic elements, because there's no, like, swapping them would just give you the same thing because it's just bromine and bromine you're adding. But if you're adding things like HBr or HCl, that's going to be adding, or obviously the H2O, that's adding 2 different things across the double bond. So this is where you can end up getting your 2 different products. But like I said, this happens when your alkene is not symmetrical across the double bond. So if I take an example of but-2-ene, okay, so but-2-ene looks like this. So if we were to do an addition reaction for this, so let's this time add HBr, or HCl we'll go with. So if we open up, or draw the alkene again with no double bond on it. So we could put the H here and the Cl here, or we could have done it the other way around. So we could have put the Cl here and the H here. but this would just be the same thing, it's just a mirror image. So if we were to identify which carbon number the chlorine is on, because that's like a special atom, then we would be looking here to number closest to the end of where it is, so that would be carbon 1, 2, 3, 4, so it's on carbon 2, and then in this one it's also on carbon 2, because we would always number closest to where the functional group is, or the halogen atom is. So this is actually the same molecule, so it's only forming one product. Okay, and this is because, like I said, the alkene is symmetrical across the double bond. So you've got 2 carbons on this side and 2 carbons on this side of the double bond. So if the alkene is symmetrical across the double carbon-to-carbon bond, then you will get only one product. Okay, if it's asymmetrical, so like this one here, you've got 2 carbons on one side, 3 carbons on the other, that's the instance where you would get 2 products. Okay. Asymmetrical alkene, therefore 2 products. Okay. Sometimes you'll be given one of the products and asked to draw the other one, so all you need to do is swap the atoms that have added on, or the groups that you've added on around. Okay, so yeah, that's it really for addition reactions. The other one, adding chlorine, that's classed as chlorination. So just try and remember these specific addition reaction names, but most of the time you are just drawing the products, or sometimes you can be asked to reverse it. So if you were doing the dehydration of an alcohol to form an alkene, you would just remove a hydroxyl group and then a hydrogen on a neighbouring carbon, and then you would add your double bond back in there. Okay, so that's the common things that will get asked on the addition reactions. Trying to identify one, so that's where you would look for 2 molecules joining to form one molecule, drawing the product of one, naming a specific type of addition reaction based on what you're adding, and then identifying which alkenes would give one product only or potentially 2 products. A lot of the time they're in the multiple choice section, so if you just sketch out the alkene chains, you should be able to then see if they're symmetrical or not, and normally the answer is the odd one out if you do forget which way around it is. But just remember, if it's symmetrical across the double carbon-to-carbon bond, that only makes 1 product. If it's asymmetrical across the double carbon-to-carbon bond, that will make 2. Okay, so I hope that helps. If you found this useful, please give it a like. Don't forget to subscribe, and I'll see you again soon.